Welcome back, physicists or chemists? Sure, we'll say chemists at this point. Now, last class we left off by talking about physical changes. One important thing that we need to be really careful about. I'm not going to write this one down because we'll see it elsewhere. If you see a change in color, it can be one of two things. First off, we haven't spoke about it yet, but changes in color are really common when you deal with chemical reactions. If chemicals react, ingredients rearrange themselves and you change stuff. A chemical reaction is very different than a physical change. Chemical changes are different. Yes, miss?
Is it like how they have the two liquids and when you pour them in, it takes a second and turns black?
Oh yeah, absolutely. So that's an iodine clock. Another, probably more common, is if I have a stain on my shirt, I bleach it. The bleach doesn't just physically remove it. The sodium hydroxide ions bond in there and it pulls it out through a chemical reaction. Now, there are situations where things that we do to make physical changes could change color temporarily. Let's imagine metal that we're going to heat up. Not necessarily, we don't want to melt it, I just want to heat it up. If I have a block of metal that I heat up to 1,000 degrees Celsius and it hasn't started melting, is it going to look like regular metal? What's it going to do? It's going to glow red, right? Now, be careful. That change in color is a pure result of the temperature and how we interpret energy with our human eyes. It is not a physical change. It's not a chemical change, I'm sorry. Color, when you look at changes, and we will see them, we need a chemical reaction. Now, moving forward, what I'm much more concerned with is that idea of separating things out. So, one of the ways that we use physical changes all over the place, and you use it whether or not you recognize it, it gets used in your lives as well. The first big one that we're going to talk about, and we'll talk about just one main one, I guess, but how does one, including us, how do we go about using physical changes? Okay. Now, human beings, have you guys ever heard of the rule of three?
Yes.
Okay. So there's, depending on how it works, there's a dark version that if you work in the healthcare field, there's a rule of three. But there's a rule of threes as well with, like, human life. The average human can live how long? Like, how long can you wait or be without oxygen?
Like 2 minutes. 3 minutes.
3 minutes. Now, it varies, right? Like, the record for somebody holding their breath is like 20 minutes, which is insane. People can do it. Can you guys hold your breath well?
No. Yeah.
I bet I could get about a minute, minute and a half, maybe a minute and a half.
A minute and a half is
I could, I'm confident I could get a minute right now if I wanted to. Okay.
Actually, yeah, maybe I could get a minute.
I think I could get a minute.
Okay, if I'm just sitting there, yeah.
Oh, yeah, for sure. Now, when you see the world record, like David Blaine, he's a magician, a performer that did it. He was just in a tank of water on stage, and he was just sitting there like this in the water, just holding his breath. Now, when you think about it, though, free divers. Do you guys know what free divers are?
Yeah.
Okay. They're just,
That's
yeah.
crazy.
Free divers can hold their breath for like 10 to 15 minutes while swimming. Okay. Addison.
What's the other one? The 3 minute rule.
No, we're getting there. Okay. 3 minutes roughly is how long you as a human being can live without air. How long can you live without water?
3 days.
3 days.
In
Okay.
3 weeks.
3 weeks without food for the average human. We're pretty good, and our bodies are pretty good about if we don't have food to eat, it just starts eating itself, and there's just a limited amount of energy inside of your body that your body will metabolize to make energy out of. 3 minutes without air, 3 days without water, 3 weeks without food. Now, is that a steadfast all the time, exactly that amount of time rule? No, but it's a pretty good guide. Okay, if you ever get lost in the wilderness, shelter's your first thing, right?
Yes.
Then what's the next most important thing?
Water.
Food, whatever. Food, like you want food, you need food eventually. Water is the one that you really need. Okay, now physical changes turns out because we need water, fortunately for us, we live on a planet that 70% of the surface is what?
Salt.
Water. But it's salt water. Can you drink salt water?
Yes.
You physically can drink it. What will happen to you though if you drink salt water?
Dehydrate too.
You get violently sick. You could die. Just like,
Boil it and put normal water.
can you?
Yeah, I don't remember. I'm pretty sure
Huh.
you boil it or you find like a puddle or something.
All right, so let's just discuss this. I don't like calling it boiling. We're going to discuss a new word. We are going to give ourselves, and I'm going to make that I with serifs, we're going to be discussing distillation. I-L-L-A-T-I-O-N. Distillation. How many of you guys have ever seen this word?
No, I've heard of it.
You've probably never, some of you might have. There's two contexts for which you might think of this. More commonly, you do not see the full word. You look at the past tense. If something has been run through the process of distillation, it has been distilled. There is distilled water commonly available at stores. What's distilled water?
It's like a jug of water.
It's a jug of water. Now, there's an easy answer. It's water that's gone through the process of distillation. Why would we do that? And what is distillation even?
I saw a video.
Isn't that the water that fish can live in?
So fish can live in any water that has oxygen and not terribly polluted.
I thought they weren't supposed to go in sink water.
So the chlorine in sink water could be detrimental, but they would live briefly.
Just for a little bit.
Maybe. It depends on the size of the fish, I suppose.
Oh,
And whether they need salt. Anyway, distillation, here we go. We have a very specific idea here. Distillation is the process, ladies up here, process, as we're looking at it, of separating a substance through two specific phase changes. Separation of a substance. Now, before I write substance, more so than substance, I would like to write solution. What's the difference between a substance and a solution?
Solution is a homogeneous mixture.
It's a homogeneous mixture, right? Now, we're going to say, I could say substance. I'm going to write liquid solution. Could be water, could be something else, but separation of a liquid solution and dissolved solids. Now, we have not seen the word dissolved yet, I don't think. We've probably mentioned it. Can somebody tell me what it means to dissolve something? If I have, for example, salt, like table salt, and I pour it in water and I stir it, does that salt just still sit at the bottom?
Like vanishes.
It kind of vanishes. It doesn't really vanish.
Like it breaks apart like that. Not that.
So, kind of, and we can talk about that in more detail. But salt dissolves in water. You just have salt water, and now you don't see the salt, you just see salt water. Okay, it breaks apart. There's some specific things. Salt is dissolved in ocean water, just so you guys are aware. Is there solids in the water that you drink? Do you think that have been dissolved? Yeah, where do you think the solids come from?
The distillation plant. I don't know.
So maybe from the water plant. How does the water get from the water treatment plant to your house?
The mountains.
Pipes. What are pipes made of? Metal kind of rusts, right? Now, hopefully not, but sometimes, yeah, absolutely. Lead pipes are common. However, there's metals that will degrade a little bit. Does water have a taste?
Yes.
I think so. I think water has a taste. It does. Water here tastes different than Anchorage. Why?
Because it's city water and fresh water. It comes from different places.
So it could be that it comes from different places. I would say that the treatment center in Anchorage is probably more involved. Not that we're uninvolved here, but you have to treat a large amount of water, and maybe they get dirtier water in Anchorage because there's more people. Makes sense. Now, when you treat water, commonly you're going to find there's a bunch of different stuff in there. Calcium shows up in water. Everywhere else in the world, not everywhere else in the world, but in this country it's really common to add fluoride into water, which is fluorine.
Oh, we don't have that.
We don't have fluoride in our water. Do you guys know why fluoride is added to water?
People's
Teeth. Toothpaste, one of the main ingredients is fluoride, because it helps to restore the enamel on the outer coating of your tooth. Most places in the U.S. put fluorine in the water, which means like for babies and children, young toddlers that don't know how to spit out toothpaste yet, you typically brush their teeth with non-fluoride toothpastes or use just a little tiny bit. Here it's less of a concern because we do not fluoridate our water, which you don't have to. Sorry? It's part of the reason, absolutely. If you start adding minerals to make sure that dietary needs are met by whoever's drinking the water, you start to get a minerally taste in your water. Well water tastes very different than water that's been treated. Very different. Now, it can be gross. As we're looking at this, there's an easy example that we're going to examine here in a second. Distillation is a separation of a liquid